Guys, what's up? Today, are you studying well? I think you have enjoyed a lot in the previous lecture of the network series as well as the control system, and now we are going to the signal system. Okay, in this signal system, we will see about the system, what is system, and how many types of system are there, and after that, we will solve the various problems related to the various type of system. Okay, now see the system, what it is. Actually, system is nothing but if there is some transfer function, if we give it some input, we get some output. Okay, input is also called known as excitation, and the output is known as response. So we can say that a system is nothing but an operator that map the relation between input. A system is nothing but an operator. You can say that an operator that map an operator that map the relation between input and output. Input and output are treated as system. Okay, an operator that map the relation between the input and output, that's known as treated as the system basically. Okay, so system may be of various type. Here we are studying signal and system. So signal, mostly there are two type of signal, three types of discrete, digital, as well as continuous. So for time domain, we will discuss. Let us suppose this is type for time domain, that is continuous CTS. Okay, continuous time signal is there. Okay, for xt as an input, that is the excitation, and after processing to the CTS system, continuous time system, we are getting the yt as an output. Okay, that is nothing but x of t. This is processing of this xt. Okay, so this is sometime a transfer function is there. Okay, so sometimes we have to give in design or synthesize, design the system or synthesize system. Sometime we have to analyze the output, what kind of output. So now there are various ways to represent a system. It can be represented in a direct expression. There is a direct expression. Through direct expression we can express the represented system. Through various equation, impulse response, and states with various through transfer function we can also represent. Like it is differential equation we can represent. In transfer model we can represent. In impulse response we can represent, as well as with state space like matrix, where we find the value of a, b, c, d as a parameter. So differential or difference equation differential. Okay, differential dy by dx. Okay, or ds square and like this type. Or transfer function we can send it like hs or hz like this. Okay, now we can see that in here gh differential in transfer function we represent this system by this like cs by rs, output upon or input. Here we represent st equals to y of t into x of t. Here it is like this. So all are these methods for which we represent basically the system. Okay, now one thing I would just like to add up here, that there is various type of signal system like linear, stable, and invertibility system. Okay, invertibility system, time invariant system, causal system, static system. So there are various types of system, but among these there are 6 types. Basically we will discuss linear, stable, invertible. So linear, the opposite will be nonlinear system. Stable, unstable system. Invertible, vertible system. Time invariant, so opposite time variant system. Causal, anti-causal, or non-causal system. Static, dynamic system. So linear, stable, and invertible system, they are mainly with respect to amplitude. We study with respect to amplitude, and time invariant, causal, and statics mainly with respect to time. We study. So linear, whether this system is linear or not, we just basically find out system with respect to an amplitude, stable or not, invertible or not. But with respect to time, we find that time invariant, that dependent or not. Causals for its for present or past value. static also or dynamic. So these are all with respect to time, and the above is with respect to amplitude. That is maybe 1 marks question given. Now I will discuss linear type of system and non-linear system. The first topic of first system is linear and non-linear system. Okay, so linear system क्या होगा? Linear system a system which ऐसा सिस्टम जो कि स्केलिंग, दैट मीन्स एडिटिविटी और स्केलिंग को फॉलो करो. एडिटिविटी मतलब ये एडिटिविटी मतलब हो गया हमारा, या इसको बोलते हैं होमोजेनिटी ही बोलते हैं. हम देखेंगे कंबाइंडली होगा ये सुपर पोजिशन. The system which follow basically the principle of superposition is known as the linear system, and which it does not follow is known as nonlinear system. We will go through the various example. Okay, just take a 5 minutes break. Hey guys, so I think lunch is over. That means breakfast. Breakfast is very important because it's boost of your body. If you take a breakfast now, then I think no need to take a lunch. Breakfast is very important as compared to lunch and dinner. Now see, we are just starting to the linear and nonlinear system. A system is linear only when it's follow the principle of superposition. Superposition means that it's the principle of additivity and the scaling. Scaling is nothing but homogeneity, and we'll see one by one. Now, what is additivity? Additivity क्या है हमारा देखेंगे. फिर उसके बाद हम एडिटिविटी, अगर हमारा कुछ सिग्नल है, कुछ सिस्टम है x1t, सॉरी एक सिग्नल दिए और हमें मिला y1t आउटपुट. ओके, फिर हमने दिया x2t सिस्टम में, तो हमें मिला y2t. ओके, एज एन आउटपुट. अब जब हम एडिशन करेंगे इनपुट को x1t प्लस x2t जब देंगे तो हमें मिलनी चाहिए, तो हम ऐड करके दोनों एक साथ देंगे किसी सिस्टम में, तो हमें मिलनी चाहिए y1t प्लस y2t. तो ये दैट इज, अगर ये फॉलो करता है तो दैट इज द प्रिंसिपल ऑफ एडिटिविटी हो जाएगा. स्केलिंग क्या बोलता है, या होमोजेनिटी बोलते हैं. होमो मीन्स सेम. हमें तो अल्फा अगर किसी को स्केल करते हैं किसी भी सिग्नल को इनपुट में, तो और हमारा जो आउटपुट भी स्केल होगा सेम वैल्यू से, तो दैट इज कॉल्ड प्रिंसिपल ऑफ एडिटिविटी. ओके, तो हमारा यही बोलता है लिनियर सिस्टम इज लिनियर व्हेन इट्स फॉलो द प्रिंसिपल ऑफ सुपरपोजिशन. अ सिस्टम इज linear when it's follow superposition principle follow करेगा, तो that is linear. and a system which is not following a superposition, which is not additivity as scaling, जो नहीं करेगा तो that is non-linear system. Now see one problem based on the linear and non-linear. देखिए, हम एक प्रॉब्लम करने जाएंगे, चेक करेंगे कि सिस्टम लिनियर है कि नहीं है. ओके, देखिए क्वेश्चन हमारा है y t इक्वल्स टू स्क्वायर ऑफ t. एक्स स्क्वायर t है, कोई सिस्टम है हमारा एक्स स्क्वायर t. तो ये कैसा सिस्टम होगा देखते हैं. पहले तो हम एडिटिविटी निकालेंगे. तो हमने स्क्वायर दिया, तो हमें आउटपुट में y1t मिला, ये दिया तो ये मिला। लेकिन जब हम ये देंगे तो क्या y1t प्लस y2t मिलेगा? देख लीजिए, एक्स स्क्वायर टी प्लस एक्स टू स्क्वायर टी प्लस 2x1 t इंटू x2t इज़ नॉट इक्वल्स टू व्हाट? दिस वन y1t प्लस y2t। तो ये हमारा ये होमोजेनिटी, ये जो हमारा एडिटिविटी को फॉलो नहीं करता है, क्योंकि ये हमारा पैराबोलिक सिस्टम है, पैराबोलिक फंक्शन है ना। तो एडिटिविटी फॉलो डज नॉट फॉलो, सो इट इज़ नॉन लीनियर, ठीक है ना। लेकिन अगर हम बात करें अगर y t इक्वल्स टू अगर x t रहेगा तो इस फॉलो में करेगा। क्यों? क्योंकि यहाँ पे x1t प्लस x2t इक्वल्स टू y1t प्लस y2t, और स्केल करेंगे तो अल्फ़ा x1t प्लस अल्फ़ा x2t इक्वल्स टू अल्फ़ा y1t प्लस अल्फ़ा y2t। ये ऐसा हो रहा है, या हम कॉमन ले सकते हैं अल्फ़ा x1t। हमने इधर स्केल किया इनपुट में, तो हमें y में भी स्केल मिला। तो ये हमारा लीनियर सिस्टम है, लीनियर सिस्टम, नॉन लीनियर सिस्टम। अच्छा, अगर हमने शिफ्ट किया, इफ़ वी टेक द सिग्नल एज y t इक्वल्स टू x ऑफ t इंटू शिफ्टेड वर्जन ऑफ, हम लोग 4 से शिफ्ट है ये सिग्नल, तो कैसा सिग्नल होगा?